بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we'll continue our course in the HVAC course of KNX. In the last two chapters, we talked about two things. In the first chapter, we talked about the concept of the HVAC. We talked about the energy, the different type of energy, how to convert energy, and how to measure energy in general. Then the second chapter, we talked about heat generators. We talked about the different types of heat generators, the heat distribution in general. In this chapter today, we'll be talking about heat generators and how they work, their types, and how they operate. Okay? As we said before, the HVAC chapter, or the HVAC course in general, is intended to close the gap between the KNX engineers and the HVAC engineers. It's not intended to give you a full idea about how HVAC works, because this is not our job as KNX engineers. Our job is to integrate our systems as KNX systems with the HVAC systems in general. Okay, let's move on. So today we'll be talking about the heat generators. The heat generator we are talking about is, first we had something called condensed boilers. Because before the condensed boilers, we had something called low temperature boilers, which are not used anymore. So they were removed from the courses in this chapter. So in this chapter, we start with something called condensed boiler. The idea about the condensed boiler in general, that, or the heat generation in general, that you have some kind of fuel. In this case, it can be oil or it can be gas, and this fuel, and in this fuel, when you supply this fuel to the generator, okay, so we have here the fuel. When you supply the fuel to the generator, then you are getting heat generated. From this heat also, you are getting some kind of vapor coming. You can even condense the vapor and get it from in the exhaust. So this is a very simple way of the condensed boilers. So condensed boilers, which burn natural gas or heating oil. This is the standard heat generator used for residential and functional building. This energy includes the evaporation heat from water vapor is known as calorific value. Okay. Another type is called the combined heat and power, CHP. The idea is very simple. When you are trying to generate power, like electricity, you are normally getting heat as well from this process. In this idea, he is taking this heat from the generation of electricity and using it also as a heat generation source. So the idea that in the normal one, the separate electricity and heat production, you can get energy efficiency like 55% because the other heat is lost. Okay. In this way, in the CHP ones, we are using this heat as well. So the lost heat is almost only 13%, and you are using the heat as well. So you are getting an efficiency of almost 87%. So this is the modern way of generating heat and electricity without losing power. So in a conventional power plant, the normal one, for getting electricity, electrical energy is produced by a generator driven by a motor, and the waste heat generated by this process is expelled unused via the exhaust. This is a normal way to get electricity. The heat, okay, is not used. In combined heat and power plants, which is the CHP, the heat contained in the exhaust gases or in the internal combustion engines cooling water is used. In this way, I'm using the heat. Both sources are used as heating or process heat to ensure a high overall efficiency. And this one is the most efficient way to generate heat. The heat generators in this way, you also consider them as the efficiency. The conventional coal-fired power plant, the normal power plant, giving you an efficiency between 30 and 40%. Okay, depending on the technology used, but the CHP has an efficiency of almost 80 to 95%. Okay, this is calculated by adding together the electricity you are getting from the generator, plus the heat you are also getting from the generator. In this way, you are getting electrical heat or electrical energy and thermal energy. When you add them together, you are getting total efficiency. Okay, like this. CHP technology in more details, which you are not required to know, but it's details for you. So the motor, this is the motor, is driving the generator. Okay, the generator produces electricity, and then you are getting electricity. During the process, you are also getting vapor, and heat, which is also using in your heat system. Okay, the conversion of energy into movement also generates heat. Therefore, that exchangers are coupled to the motor. So you're getting electricity and heat as well. This is the idea of the CHP in general. This is why the CHP has a very high efficiency in producing power. Another type of heat is getting it from the heat pumps. Heat pumps, we have a heat pump, by the way, in our houses. It's in the refrigerator, where we are getting heat and expelling it to the kitchen itself. So the refrigerator pump extracts the heat from the air in the fridge and expels it into the kitchen. This is the way, because you need to get the refrigerator in a cooled way. So heat is getting out. In the heat pump, it's a different way, because you want to get the electricity, the heat to the building itself. Okay, so the heat pump, you are getting the heat from the outside air and deliver it to the room. It's exactly the same principle. Okay, this is the heat pump in general. How heat pumps work? This is how the heat pumps work. A liquid is chosen which boils, therefore evaporates at a low temperature. The steam is then compressed. So the water is boiled, you are getting steam or vapor. Then you are compressing the steam here or the vapor here. During the compressing of the steam and vapor, then the temperature is getting much higher, which you are using now for the heating consumption you need. So the steam is then compressed, causing it to heat up, and it has now reached a higher temperature. It can be used for heating purposes. The following image illustrates. Okay, so this is a heat pump normally works. So you have a heat source, which is consuming some kind of power. It might be oil, gas, or electricity. And then you are getting the vapor coming from the heat pump in the specific temperature and the specific pressure. You're increasing the pressure by compressing it, okay? And then you are getting high temperature coming from here. This is normally how it works. Then a different way of also you need to understand called something called monovalent and bivalent. It's an operating mode. You need to understand simply that in one of them, which is the monovalent one, the power, the heat pump is designed to provide full coverage every day of the year. This is if you are having this system. If you are having a different system, bivalent, okay, then normally you have an external or a secondary heat pump to give you extra power, because the first heat pump is not functioning all the year with all its function, okay? So when the heat pump is at full load, heating load, the temperature of the heat source should not fall below the planned limit condition. This is the normal way. So if the heat source must be productive enough to provide heat during entire heating period. If these two conditions are met, then you are having a system called monovalent. If that system is not meeting that, then you see a system where the heat pump cannot supply all of the required heating power, meaning a second heat generator is necessary, then it's a bivalent system. Okay? So you need to know that with the monovalent system is much more productive than the bivalent system. Now talking about a different way to produce heat as well. Now it's the solar energy. And in a very system way, in a very simple way, you have a collector area. This is a collector area, which normally you are putting it in front of the sun. And then the radiation of the sun is coming here, converted now to electricity, and then it can be converted to temperature or heating in general. So one of the most important thing about the solar system is the collectors, because they are the one responsible to get most of the power. This is a flat collector, and this is a pipe collector. Okay, and in the pipe collector you have better exposure to the sun, so more energy as well. Another way, this is showing you the solar coverage. You have here two things affecting the solar coverage. Of course, the area of the collector. If the collector area is much bigger, then as you can see in the blue one, then you have more energy. And if you go lower, then lower energy. Also, the month of the year, even the time of the year, because in the summer, you have more heat, you have more temperature coming, you have more energy coming. So it's peaking here, mostly in the June, July, August, because this is the summer. So heat is coming more, solar energy is coming more, and then it is decreasing during winter, of course. Solar energy systems are more complicated, but you need to understand that here they are affected by the type of collector and its area. and also affected by the time or the month of the year. That was in a very simple way how heat generators work. Now we'll talk about also drinking water. After that, we'll talk about the legal framework. Two chapters, very small, short chapters. We talked about them in a brief. The drinking water is simply here. We are talking about drinking water is necessary for life. This is simple. But how the quality of the drinking water is governed? Can I drink any water? And this is what the chapter is about. So here it's saying that there are some standards for the drinking water, like a German standard here. Okay, and drinking water is defined as the water intended for a human consumption must be obtained in such a way that its consumption or use possesses no threat to human health. So that drinking water should not affect the human health by any way. Okay. Quality of the heating of the drinking water, the quality requirements are it should have low germs, okay, and may not contain any harmful pathogens. Of course, this should be like that. It should be appealing, colorless, so no color, cool, odorless, so no smelling or anything from it. Okay, and tasteless as well. So it should have no color, no taste, and no color, no taste, no smell as well. Okay, its temperature should be between 5C and 15C. There should be no short-term temperature fluctuations. What else in the quality requirement of the heating of the drinking water? While dissolved, substance content should be limited. Certain salts, so maybe you can put some salt in it, okay? But you shouldn't put other materials that will not be dissolved. When heated, so if you are taking that drinking water, heated it, then the hot water leads to sedimentation in containers, so it might lead to some kind of residuals in the container itself, which might lead to corrosion of the container of the pipe itself. So you need to avoid this as well, and there are some systems will avoid that. Also, hot water will cause fire, okay? So if it is around 50C, it will only redden an adult skin, but will be harmful for kids, okay? Any temperature more than 50C, so if 60C, it might endanger your life. So the hot water and pipe network should not exceed 60C in normal operation. Scalding prevention, meaning that prevention to make sure that the water is not getting to that heat limit, okay, are being used in the thermostats to limit the temperature as well. Okay, that was a chapter about the quality of heat, the quality of water, as I told you, it's a very small chapter. Another short chapter is talking about the legal framework. The legal framework here is talking about mostly that there are some standards to cover the building. So can any building be built without considering the heating requirements of the building? No, it's not correct. So we're talking about the legal framework and the standards governing the building. So in contrast to standards, okay, when it comes to building energy, regulations are instructions issued by the lawmakers. So regulations are more uh, mandatory to involve other than standards, okay, because they are issued by the lawmakers, people who are putting the law, and are thus mandatory. Over the last few years, statutory energy efficiency targets have been considerably increased. For example, up to 30% less CO2 emissions in some European countries. So they're putting more regulations in each year, in a certain amount of climate distribution. Differentiation is also to be achieved. These targets can only be reached in new buildings and the comprehensive renovation of all the building using building automation. It's saying that in some standards, some regulations, you need to put some kind of regulations in new building, but in the old buildings, you will not be able to do that. So you should use the building automation to enforce specific quality of living and emission of some gases. So this, an energy certificate, this is one major energy certificate from German, okay? Normally you get this to ensure that your building is under the limits put by the lawmaker, okay? So it should be in the green area. This is another certificate, by the way, also. So comparative value of the final energy. This now is saying everything that these are standards that you should follow or regulations that you should follow to have it, okay? So conclusion, in future, some form of automation technology will be essential in all our buildings. This also applies to renovation of old buildings. That's it. This is what you need to know, understand about this chapter. So we'll talk today about these chapters. Next chapter, inshallah, we'll be talking about steering, and adjustment, inshallah. If you have any question, let me know, and see you, inshallah, in the next chapter. Take care.